Now, we are very fortunate as living creatures to live in a universe which is in a highly non-equilibrium state from the get-go, as we say. And how do we know this? Well, we know an amazing amount about the early universe. This is a map of the temperature of the night sky. And the temperature of the night sky, if you look past all the stars, past all the galaxies, is about 2.7 degrees Kelvin, and very close to absolute zero. And that is the heat left over from the Big Bang. Just a few 100,000 years after the Big Bang, the universe became transparent, and the heat from the Big Bang was released, and we're still seeing that heat today. It's just shifted down to this very cold temperature by the expansion of the universe. But the initial condition of the universe was not perfectly flat. It was a little bit lumpy, okay? And each of these little temperature fluctuations, which are very small, map the lumpiness of the universe at its very earliest stages. You can think of this as the kind of lumps in the primordial soup, as we like to call it. And what's interesting about that is that ever since that time, which is about 13.6 billion years ago, those lumps have been falling together under gravity and forming interesting structures. And they're still doing that today. And they're falling together to form, for example, stars and galaxies. This is a very humbling picture because it shows a survey not of stars, but of whole galaxies of stars, galaxies that contain billions of stars. Each of these little specks in this picture is a galaxy, and there are thousands and thousands of them here. And you see that the universe is a kind of, it's not uniform, it's a kind of foam or lumpy mass. And it is believed that these galaxies are actually falling together from those primordial lumps that I showed you in the previous picture. And we're looking out here almost 2 billion light years into the past. And so as the matter in the universe falls together, it forms stars. Stars produce higher elements. They send heat to the universe and so on. And that process is ongoing. So ultimately, the universe's entropy is constantly being produced and produced and produced. The universe is a very non-equilibrium place. If we waited an infinite length of time, the universe might become boring. But believe me, that's going to be a very long time from now.